Yeah, go ahead.
Oh, starting a recording?
Yep.
Hey, can I ask a quick question?
Yeah.
So how do you want us to what do you expect us to submit? Is it just a screenshot, or you want us to upload the VPN file, or how do you want to do it?
You can, what I was thinking was to simply take a pic of on your phone when it's connected. Just hit those two buttons on each side, and it snaps a photo of your screen that says it's connected. And then just do a print screen with, or do the, it's the Windows button, the Shift key, and the letter S all together is the new sniping tool. And you can just highlight and show where you down on the bar at the bottom where you connect it to your VPN to just grab that and just show that you're connected both to your PC and to your phone. So yeah. And then you can just dump that into a Word doc and upload that to Moodle.
I have a question about some vague language in the prompt. First of all, it says create a Linux Ubuntu VM, but it also says actually to make, I think it's more accurate, we're supposed to choose a server of like a Linux server in AWS, right?
Yeah.
Like of the types listed in the elements.
Yes.
And then it says configure the firewall in AWS. Does that mean the security groups?
Yes. That's right. Okay. That's what it means.
Because it's like the words are being...
Now remember, this is a list of instructions from its own cloud service provider called DigitalOcean, right?
So you could sign up with DigitalOcean if you want, or you can
get a
do
free
AWS.
account with Digital. Yeah, exactly.
Hey Mark, can you go over Azure for those of us who has problem with AWS?
Yeah. All right, let me just minimize this. Okay, so if we go into your account and somebody was not able to go into there, right?
Yes, I wasn't.
I was going to mention some of us have been having issues where like it creates a non-student account, and I don't know how I got mine to work because that was my original issue, but now mine is working.
I couldn't figure out how to get it connected to like the AWS Educate, so I just had to make a regular account and just do the 1-year free trial.
Oh
yeah, I tried.
They're going to charge you hard. I got charged.
No, they're not going to charge you, Gary.
No, I made a regular one because my Educate one didn't work, and then after a couple months or like a month after, they charged me $12.
Did you leave the virtual machines like running?
No, I mean not part because I thought I was on the Educate one because I was using the free trial and I used my education account or whatnot. But I just like wanted to warn you, if you any chance put your credit card or card information, you're wrong. They will going to charge you. But if
I couldn't figure out a way to get to this screen that's up right now without
doing they're not going to charge you. Gary did something wrong.
Yeah, but hey, did you put your credit card information though? Or not?
Gary makes a statement like it's truth. It's not truth. They're not going to charge you. If you create an account and it's a free year account, if you go beyond what the free tier is, which is 750 hours in a month, and that could be a combination of 1 or 2 servers, then you can be charged. Or you use services that are not part of the free tier, then yes, you can be charged as well.
I think Gary might have left one of his like instances running.
No, not about that. I was only using one EC2, and again, they said that wasn't, even if I was using education and whatnot, they said that wasn't a actual Educate one. They gave me a link. I told them that, hey, I signed up with it, but didn't give me a console to get into it. The one that Mark was getting in with, it wasn't a regular AWS website. It was through the student support or student something, and then they said those two are two separate entity, like two separate thing. They're the educate or student one is not part of the AWS regular one. So
Okay.
yeah, I did exactly same thing as what Nathan did. I tried with the educate one, it didn't work out, so I went back to regular AWS account, and then I added to the education and stuff, and then at the end I got charged for $12. I called them, explained about situation, so they waived it. But I just want to have you recognize that if
Yeah.
you create, or like Nathan did, if you made a regular AWS account, then you're not using a student one. Well, I might be on these.
Again, I couldn't access this screen with a student account.
Hey,
Yeah.
I was on the same
Gary,
thing.
it's okay. Gary, it's okay. If you created an account, it's a free account. It is going to be free for a year. They're not going to charge you. You do have to be careful what you do.
Just make sure
Gary is not using AWS at all right now. What are you using now, Gary?
Yeah, I'm using Azure from the
Using
Microsoft.
Azure.
Yeah.
And you went and what? You got a free account with Azure?
So there's a trick
on
that
Azure too.
yeah, there's a trick that the same Martin email account is part of the Microsoft. If you just simply log in with St. Martin account and then create it, they're not going to ask you any information since they already have everything. So yeah, that's the trick.
So here's the secret here is that we are allowing you to use any cloud service provider, Azure, AWS, DigitalOcean, Oracle, Google Cloud Platform, any of these. All we're wanting you to do is to get a functioning server, a Ubuntu server, run through the instructions and get an OpenVPN server up and running. So that, yeah, so you can, it does not have to be in Amazon Web Services. That's an easy way to do it usually with their AWS Educate. That is true. And that gives you a lot of resources, and that's the biggest. And so it's good to be familiar with Amazon, but it does not have to be that. And if you create one and you launch an instance, again, they do give you free tier. Like here's the very top one is free tier. These three are not. And then Red Hat is free tier, right? And that one is not. And then this one, SUSE Linux free tier. Here's Ubuntu server free tier. You do have a little checkbox over in the upper left here. It says free tier only. Check that and it'll just list the free tier ones. And then here's Ubuntu server 20.04 or 18.04 or down a little farther, 16.04. You can select any of those. And I only am saying Ubuntu server because I found that nice sheet, and I've done my own to just build it, but it's just easy to just follow the DigitalOcean VPN instructions, and you can walk right through those. So in that case, if you use 20 or 18, just use the specific instructions for 20, 18, or 16, and you just simply select it. And if you stay within this free tier, they shouldn't be charging you for the amount of CPU and memory and IO that you're using here, if you stay within that free tier. And launching that again, there is some confusion getting into this. Once you have launched one of these boxes, how do you remote in? And you remote in using some type of either, you can do it from the command prompt. If it's like a Mac OS, SSH is already built into Mac. You can just go to a command prompt and use the SSH command, including your PEM file that you generate when you save the information about this. Remember that PEM file? So when you go to that PEM file is going to allow you then to send your hash, your password, username and hash to that versus your actual username and password. And so it's more secure that way. So when you look at that AWS.
How do we use it though?
Okay. So how you use it, in my case, if you use just a PEM like that, and you see the file, it's just a hash of your username and password right there that you pass to it. I think it's just the password actually. And then you log in. But how you use it, it depends how you use it. If you go to a command prompt, you can use that command. And if you just say, okay, I've got the Mac OS, SSH login, to Linux. And it's going to be the SSH command at a secure shell. So with that secure shell, you would just type in the big long name. It's going to be SSH, the IP address. You've got to dump in the server, your username, and you also have to have the option to throw in your PEM file. Or you can use some type of SSH client. So in the case that I was showing the example last time, I used Putty. Now this Putty, P-U-T-T-Y, is a program that's been around for years and years. It's just a simple GUI-based SSH or Telnet or RLogin or serial client. And in this case, we are just putting in the information here for the host name, the port, and you can save that session with all the information. And if we look at how to use Putty, there's 2 steps to using Putty. If you use Putty, okay, then what you do is, here's my Ubuntu here. Let me load it. I put a name. I called it Ubuntu 2004. Let me just zoom this for you. Okay. So I used these settings. I put a name in to save it. I put this user Ubuntu right here. And then after it, after the @ sign, I put the fully qualified name of my my server. And in Amazon Web Services, the fully qualified domain name with DNS. Oops, sorry about that. All over the place. What happened here? Okay, let me try and zoom it up again. Be careful. So then I've got, okay, it's over here. Okay. With this, then as part of the name, okay, I cannot touch this thing. It goes crazy on me. Okay, right there. Stay. So I put the name in. By arrowing, it's throwing it around. That's bad. I'm going to escape out. It's driving me too nuts. Okay, so I threw in this Ubuntu at EC2-54-190-165. That's your IP address. That's your public IP address. .us-west2.compute.amazonaws.com. And so where does the PEM file go? It goes over here on the left under SSH. You expand that and then auth, and it's right here. Okay, let me zoom this up. And I won't move it around. Okay, so under auth, I went into SSH, I went to auth, and under authorization is this directory right here is the directory pointing to my directory on my hard drive for my file, but it's not a PEM file. I had to convert it because Putty has been around so long that they require a PPK extension. And so I had to do a conversion, this little conversion. That's the step that throws people. So instead of this saying, okay, PEM on the end, that's what you got from Amazon. I had to convert it to this PPK file with this .ppk extension. And it's a little bit different looking. And the look of it is looks like this. you've got a private section, and then you've got, private section at the bottom here. And you have a public section up at the top, the first 6 lines. And then you've got this information here. So it slightly modifies it. And then you use that as the file. And how you did that, how you got it to be like that is there is a thing called, when you install Putty, there is a Putty Gen that also installs, and it's a conversion utility. So this Putty Gen is a conversion utility. And this Putty Gen, you take this and you load your other PEM file. And once you load your PEM file, okay, like Ubuntu key and open, pulls it in, successfully imported. And then you don't put a key passphrase or a confirm passphrase. You just save the private key. That's the secret. Save private key. So you save private key. And you say, are you sure you don't want to save it with a key passphrase? And you say, yes, I'm sure. And you save it with that PPK extension. And I just name it the same name, just have the different extension on there and save it into the same directory. So once I've got this done, then with Putty, this PPK file is selected. I just browse to it and select it. And I went back up to session up here on the left over here. That gets me back to the main screen. I put in a save session name. You can put whatever name in, and I saved it. Because then when I come back in, I've always got these here. I can just double click on any one of these, whatever I'm doing, and it goes in to those. All right. And so these save sessions just save me the time and effort to re-add all that information into my Putty or my SSH client. Does that help? Any questions? Was it Daniel?
Sorry, yes.
Did that help?
I'll have to, I can rewatch the video and then it'll help. And also I do have a question. With the like Ubuntu server, do we use like EC2 to interact with it? Because that's the only option I had.
Yeah.
Okay.
Yeah, you just in there and you select that that EC2 instance. That's basically your virtual server, virtual machine, VM. It's yeah, that's it goes by different names, but yeah, that's what it is.
Because the example you did like a couple days ago used like the RDP to connect with it, and the Ubuntu didn't have that.
Oh, yeah. So that was a Windows box. I had selected
Yeah, I
Windows.
noticed.
Oh, yeah. So yeah, when you select Windows, it's a little different in that you have to use remote desktop protocol. Instead of port 22 like SSH, you use port 3389, and it has its own client you have to download and configure. And so it's a little different. Yeah, you're right.
Yeah, it didn't even have the option though.
Yeah, it won't even have it. Ubuntu, Linux is different than Windows. In fact, that when you install that, because it's a server, you're normally not on it, and so there is no GUI. You usually interact with it from a command line, or it's something else, or you are using some app, some web front end app that's on the server. So you never need the GUI. So why install the GUI? So Ubuntu does not have a GUI. Well, it does have one, but it doesn't install automatically like Windows does. So you could technically go in using SSH to the command line, then install the GUI X Windows on Ubuntu. Then you could use what's called XRDP or some other, there's other different graphical based remote access clients that you could use. and that could get you in, and you could see the GUI and use the GUI of Ubuntu to do configuration. But in the
All
end,
those require install and configuration. So
yeah,
it's
so
a little bit of work to them.
And this whole command line thing, that was the instructions anyways with DigitalOcean, was just to go to the command line and then just run those commands. And every one of those commands, of course, typically you have to do sudo or superuser do in front of it because you're the Ubuntu user, not root. So you don't have those you don't have all rights by definition.
But if you use sudo, then it works fine still.
Yes.
Yeah.
Okay.
Yes. It's kind of like I'm not super user, but if I put sudo in front of it, then it lets me do it. And it's just like this little weird deal that says it's safer to do it this way, where you don't have all rights automatically without using that super user do command at the beginning.
Okay.
Okay.
Well, I want to say that when you install Ubuntu, it actually comes with the graphic interface and everything, but the way you can access to it is you need to physically access to it and connect all the cables, your monitors and whatnot. Then you will see the graphical thing. But since we don't have access to the physical server or where the machine installed at, we are using SSH, which is port 22, that doesn't support GPU thing, but that will support command line. I put it in the chat that there is softwares there is a support software that will allow you to get access with the graphical interface, which is usually require port 5900 or 5900 to like 6000. And the most famous one is VNC, or you can use TeamViewer. Install that in that server, Ubuntu server, and then open that port in, then you will be able to see the whole graphical screen. Just matter of fact that doesn't come with it. The port 5900 is not coming with it, so you'd have to configure and whatnot.
Okay. Yeah. So all of a sudden we're realizing there's lots of ways to do this, and but we're learning. That's the whole beauty about this, is the more we do this, the more we figure it out. And okay, and we can continue to answer questions as we go along, and we can also have some other questions maybe by Thursday, or if you're working on this. Gary, did you get your VPN working?
Yep, it was hard, but yeah.
Real quick, in like a minute or so, what were some of the gotchas you found? Rights?
Right was one of them.
Like directory rights or file rights?
It was file rights. But let me actually go over the instruction so I can, because it's been a while that I did that.
Oh, it's upside down. There is a command.
Oh, not the right. It was I had two separate machines that they need to communicate each other. You have to transfer files to each other, but getting a SSH key for each other uploaded or copy and pasted, so those two machines can communicate each other, was the hardest part. So when you do SCP, you're using SCP to transfer file from one machine to the other machine. You would have to include your PEM file or your key included. Otherwise, they can use SCP each other. So that was the hardest part for me.
Secure copy?
Yep.
Because you have to take that config file and you have to copy it to your client. you can do that. All right. Two gotchas right there. Of course, you've got to take that PEM, that PEM, convert to PPK if you want to use Putty. Okay. And then use that PPK file as part of your configuration setup to get in there for your command line interface or CLI, right? So that's your SSH client. Okay. All right. And then there's the 1 versus 2 servers. And it's, of course, it's based on doing it 2 servers. That's the correct way that their instructions say have 2 servers running, but you could put it all on 1 server. There is one that just like 16.04 with Ubuntu, LTS Ubuntu. The instructions are for 1 server. So
I think you need to upload the 1 server one, because I was trying to do under 1 server with the instruction that you gave us.
yeah.
When I did a easy RSA, it actually conflict each other, one for the CA and one for the OpenVPN one.
Yeah. Okay, well, this one here is the 16.04 one. And I can throw this in the chat and you can use that if you want. Let me throw it in there. Interesting. Oh, I know why. Why can't I? I made you co-host. Why don't I have the ability to? Oh, that's why. Let me go to more chat. There. So if you look at this one here, this 16.04, okay. If you say, oh, not using 16.04, well, here's the instructions for 14.04, 18.04, 20.04, Debian 10, 8, 9, 7, whatever. You know what I mean? CentOS 8. So they've got instructions for multiple OSs. But then this one says, this is putting it all on 1. So you need to configure a non-root user with sudo privileges before you start this guide. And you've got an initial setup guide, set up a user with appropriate permissions. And of course, they're doing this assuming you're doing all this on their site. But if you walk through this, it'll do both OpenVPN and the Easy RSA and install those both right on the same box. Generate your certificate, copy the config in, generate the certificate, copy back over, and then copy it down. You got to copy it down. That's one of the hardest parts, is when this thing gets this generating this 2048-bit RSA private key here, ca.key. Okay. All right. Yes. So this secure copy to client, this can be difficult. And you don't have to use secure copy. You could use something else. This, for some reason, is hard.
FileZilla, cheating.
I told Gary to use FileZilla. It's like this GUI. It's like File Explorer in Windows.
Well, he told me after I struggled with everything. He goes like, I did file select. He didn't go through this conundrum. Hey, you should have told me earlier.
Or
Yeah,
WinSCP is a good one too.
Yeah. Yeah, so there's more ways than one to copy this file down. WinSCP. All right, so yeah. So no, there's multiple ways to get this job done. And it's just getting that file down to your phone and getting it to your PC. The easiest is get to your PC and then just email it to yourself. And then you go into your phone and then you got it there. So as an attachment. Your one file for OpenVPN, your client file. Okay. All right, so let's talk about proxy servers. Proxy servers, if here you are with your PC, and this is your monitor, keyboard, and workstation. You're trying to go to the internet, and you have a proxy server. A proxy server is a cache for content out on the internet. Now, there's many types of proxy servers, but in this case, let's start with a simple example. If you have a proxy server and you're using your, so let's say you're using Chrome, and you point to the proxy server in Chrome, the proxy server will go out and get the content from the web server out here. It will then cache it back to here. So it caches it in memory. Okay. Now, when you go with Chrome and you go to the internet and the content is already here, okay, stored, then it's just going to give you back your information from the proxy server. And what does this do? This reduces the amount of traffic that's going out to the internet. So if you're at a corporation and somebody went to ESPN to get the latest scores for the March Madness basketball tournament, well, it's already cached on the proxy server. And therefore, if you have the configuration for everybody in your office to point to a proxy server, then they say, oh, I want to go to ESPN. Boom, very fast. It just gives that content right back to them. They're up and running with that web server, with that web content from ESPN. And it was very fast response, and they didn't go to the internet because it was already cached in the proxy server. So it reduces the amount of traffic that goes out to the internet. Instead of 10 people going to ESPN, pulling the content down separately, one person went there, went to the proxy pulled it down, and then gave it back to them. So now all other of the 9 who request to go to ESPN for March Madness to see what their bracket is, and everyone's bracket is completely busted by now, then they immediately get a response from the proxy server. They get the content they need, and so it's both, it improves performance, reduces the number of time that content has to be pulled from the internet. It reduces the bandwidth utilization out to the internet with your with your internet provider, internet service provider, all those things. So those are all good values of using a proxy server. Now, there's a reverse proxy server. A reverse proxy server, okay, is, okay, this. Okay. This one, in this case, this one is Windows. Let me just go into presentation mode so you see it. Okay. This one is a web application proxy, but it's the reverse. You're not coming from the right and going out to the internet and pulling content back. It's people from the internet coming into your company, okay, to try and get resources or whatnot. And the proxy is actually a front end for those resources. So for them, instead of going out to the source, but going through a proxy, in this case, they're hitting a proxy, in this case, a web application proxy. And so they go to these two firewalls. It's like an outer and an inner firewall. This is what's called a DMZ, Demilitarized Zone. Many terms in computers come from military terms. And a demilitarized zone is basically an area that is less restrictive firewall, outside firewall, to get to these services in the DMZ in the middle here. And then from there, you've got the ability to, I think I can draw. Is this drawing? Just do. Oh, no. Anyway, so that, so what happens is this web application proxy, then the application on the back end within that circle on the right can be hosted or can be cached into memory on the web application proxy. When the client devices on the left from the internet come in, they hit the proxy, they get the content. The proxy is updated from the original content server, the application server in the back. Okay. Now you can do web services, a web application. You can do internal resources that you need access to from corporate corporation, like corporate headquarters or something like that. And but they can be hosted or basically front end cached with this proxy on the front end. If the proxy gets compromised, it's just a copy. It's a copy of the original website or the original application. So it's not, they're not modifying content on the original server, okay, or modifying the actual web server. The web application proxy just gets a copy of that content. All right. So this is a little bit more complex, this thing, because it integrates with Active Directory. And Active Directory has several pieces of functionality that allow this to be a good solution. One of which is this ADFS, Active Directory Federated Services, okay? This is what allows Windows servers to do single sign-on. So if you go to the web application proxy, okay, then it's saying, okay, this person needs to log into this service. Well, you can do a couple different things. You can pass the credential login to ADFS, Active Directory Federated Services. Then it goes to ADDS, Active Directory Domain Services. It authenticates you. Yes, this person has rights. They can look at the database. Then ADFS holds those credentials. This federated services scenario means that if it goes to multiple applications, maybe through the same web application proxy, it's already logged in because they already have the login one time. That's what ADFS does. That's called single sign-on, SSO, single sign-on. And it can do that, or it can do pass-through, and the web application can pass through to the application server below. The application server can go up to ADFS and Active Directory Domain Services and get authentication, and then it can pass it back. Anyways, however it authenticates, it gets passed back to the web application proxy, which then passes that back to the client and says, yes, you have access, and so forth. So this is just an element of security, but the concept here is this proxy that is both safer and more secure. can allow single sign-on and is located in this perimeter network. So we're always thinking of performance, we're thinking of security, and we're thinking of functionality like single sign-on, make it simpler and more streamlined. So all these elements can be done with a web application proxy. Okay, that's a reverse proxy. Okay. All right. So now, all right. Did I want to talk here? Okay, yeah. Single sign-on. You can do multi-factor authentication, so forth. Multi-factor access control, pass-through, or ADFS pre-authentication. So you can pre-authenticate and then be authenticated from then on. So those are some benefits. Okay. So now that we've done this, this is a regular proxy, or forward proxy instead of reverse proxy. We're going out to the internet, and content is being cached in the proxy server coming back. So hopefully you're understanding the difference here. Now we have there's several proxy architectures. Okay. And you can see that there's a half proxy, full proxy, reverse proxy, forward proxy. Okay. There's DNS proxy, SMTP proxy, SSL forwarding proxy. So, but the concept is still the same. The point of it is that these proxies are providing security, man-in-the-middle type cached resource, reducing bandwidth, and providing that ability to provide easy access to content that is being accessed by multiple devices. So if we read this top paragraph, a proxy is a server that acts as a middleman, helps filter traffic, cache certain web content, help reduce web traffic. If a proxy server caches popular web content that many devices request, it limits the number of devices that need bandwidth and other network resources to reach the internet. So it reduces your overall throughput, and that way you could actually pay less. If you really could use a smaller internet pipe from your internet service provider, it could save you money in the long run with a proxy server. The devices that want the popular web content only have to go as far as the proxy server instead of having to search the internet. Proxy architecture thus reduces web traffic, caches the content, provides anonymity, provides users to bypass filters, and the proxy filters traffic that actually needs to go out to the internet versus traffic that just wants to retrieve information readily. Okay. So these are the types of benefits that a proxy is doing for us. Okay. There is a proxy, and let's talk about security. Okay. A half proxy set up initial connection, call, and the pass-through device. Streaming protocols will bypass proxy on return to improve performance. So half of it is cached, okay, and the other half is not. That's a half proxy. People talk about full proxy, or they talk about this term air gap. Okay, and air gap, what that means is there's no direct connection for your traffic. Okay, so if traffic comes in on one side, okay, if this was a full proxy architecture or air gap, air gap, what this has then is you've got you've got a piece of hardware where requests come in, okay? And then it doesn't have a direct connection out. Okay, there's no direct port specifically connected to another port. All right, what there is there's a gap in here. All right, and so this air gap, okay, in here, trying to write sideways, air gap. This air gap in the middle, air gap, oh, it's hard, looks at each packet, outbound, inbound, okay, as they're coming back in or they're going out. It's checking on these and it's saying, I am going to, is this traffic, is this valid traffic? Is it nefarious traffic? Is it a distributed denial of service attack? Is it, what is it? And so it looks at the traffic and then determines if it should be passed on. It doesn't immediately go through and trying to look at all the packets that go through, but it literally, there's a buffer of memory that it's in, it's looked at and then passed on. A very famous company, okay, that does a full proxy architecture is a company called F5. They have a famous, very expensive product called Big IP that uses as a full proxy architecture. Okay. So the clients talk to the proxy talks to the servers, or the reverse, you know, as it's coming in or going out. There's never any blending of connections. Okay, they're separate from client to proxy. Okay, and proxy to server. Okay, it connects every client independently, does its own inspection of every session, manipulates packets on either side to make sure, oh, these two are making a connection. Okay, I'm going to connect them and allow traffic to go through, but it is monitoring and managing that, every single connection. All right.
So in my mind, this sounds like a gangster movie. You always had Vinny sitting out front, and you know that no one gets to talk to the big boss, you know. So you always have to ask Vinny the question that you want to ask, and he goes talks to the big boss, and then he tells you what the problem is. So that sounds like a full proxy to me.
Exactly, that's exactly it. So it's a much safer scenario, but it's also more expensive. So the appliances that you need to set up a full proxy architecture, you can set up a full proxy architecture in a cloud service provider such as Azure or AWS, and are set up for big customers, but it's a service that gets set up for them so that, like you say, there is this proxy, full proxy architecture in the middle that's monitoring every single connection and making sure that it's legitimate traffic, and it's not just allowing traffic through and trying to just look at it as it goes through, like an intrusion detection system or something. Okay, so we've talked about half, full. We've got reverse proxy here, which we've talked about, forward proxy. Okay, this is acting on the client side, and reverse proxy is basically acting on the server side. All right, to cache content in front of it. And then there is Proxy Ssl. All right, so this is man in the middle, does bulk encryption and decryption between client and server. And so these are doing the hard effort of encrypting and decrypting and managing private keys and so forth. And then there's also secure sockets layer, SSL, forward proxy, and it's used for certificates. And let's see. There's SMTP, Simple Mail Transfer Protocol. So proxy can be used for mail. It can be a front end for your mail or for a front end for your DNS. All right. All right. So any questions up to this point?
I don't have any questions, but just when we were talking about decryption and encryption of traffic on the Palo Alto firewall, that's Proxy Ssl and SSL forward proxy. It does both of those. So basically, it acts as the man in the middle to decrypt and encrypt traffic to so that the management can see what's been encrypted on the client side and decrypted.
I did have a couple of questions. In looking at the number of types of proxies, we haven't talked about either bandwidth or I think the idea of setting up more than one proxy, is that even a thing? For example, sometimes people use a proxy to go around the outside of some secure, normally forward-looking thing. I know that, for example, you could get to some government documents not by going through their front end, but maybe there's a separate proxy server that you have access to as a group. So my question, of course, is about bandwidth, and of course about whether you can use these in combination.
Yes, you can. And in fact, that's a very good question, because there is a product, okay, called, we've talked about it in here, which is the Onion, the Tor browser. You've heard of that? The Onion router?
I definitely have, yes.
Okay, so I'll just, the Tor browser, and this is what it does is it effectively, so when you come into this Tor browser, it has to set up connections. It doesn't just go out to the internet like other browsers. It doesn't just go point A to point B, going to an actual and making a connection, doing a TCP three-way handshake, making a connection, then connecting securely using HTTPS to the web server or the front end proxy for that matter, and then requesting the content and downloading the content. So what this does is this browser, all right, if you start out with your laptop here, okay, it's going to go to a first proxy server. It's going to make a connection here, and then it's going to make another connection to another proxy. It's going to make another connection to another proxy, and it's going to make another connection to another proxy, or maybe this is the website. Okay, so you're going to a website. All right. Well, when you send your packet, it sends it to this proxy. This proxy sends it on, but the proxy after it, it only knows the previous. It only knows about the previous proxy. It doesn't know where it came from. This is the origin. But it goes here, proxy sends to this proxy. Proxy only knows about the previous proxy. It sends it on to the next proxy. It only knows about the prior proxy, okay? And then it goes to the website. When the website sends it back, all it knows about is this proxy. So it sends it to there. The proxy knows it got it from this proxy, so it sends it back to here. It knows it got it from here, it sends it to here. And then this proxy is the only proxy that knows about the origin, you. So by going through multiple servers to your website and then traversing back through those proxy servers, then the website says, well, was that actually Jonathan? Where did that come from? But it only knows about this first proxy. And if you got onto that proxy and said, where did that packet come from? It knows about the prior and so forth. So basically, the only proxy server that knew where the origin was the first proxy server that you connected to. And that way, throughout this whole stream of content, your stream is kept more secure because each of these just knows the one in front of it and the one behind it. And that's it. It's like in series, these proxy servers.
Yeah, so an attacker can know where or what you transferred in this situation, but they wouldn't know where you transferred it from.
Yeah. So it's let's say there was a man in the middle. So this man in the middle comes right here and it grabs, here's all your traffic. But the source, okay, the source, it only knows is this proxy right here. That's all it knows about. And the destination was here. So it got the traffic, and maybe it can decrypt it, but it doesn't know where it originated from.
Yeah, those
So
proxy servers could be anywhere on the planet.
Yeah.
Okay, but that raises another question in my kind of small brain on this. Whenever you have all these VPN sites who will say, oh, you can designate what country you like to appear as, that way you'll get some kind of rights to. I know a lot of people argue about the Netflix thing. Oh, good, I'm coming from Germany, so I can watch additional content. Well, the idea of having one proxy designate, does that happen on the first proxy, or can that be set up in a way? Because I would think that just like a telephone call, if you stay on too long in a designated server, at some point they might be able to triangulate some kind of connection between, like, for example, what you're viewing and what proxies is bouncing off of. So I guess it's too broad of a question, but where you want to specify a location, doesn't that normally occur on the first proxy?
Right. So when you're talking about as one of those VPN services, and basically the proxy there is your VPN service. So what you're going to do is encrypt your traffic between you and that proxy, and then it goes out and gets your content for you. And that proxy is then located in a country where you want to have whatever extra services that we don't have in your current country. And so if you say are in Germany and you want to watch American content, you have a proxy server in America that goes out and gets your content for you and then encrypts it and then sends it on to you. Does that make sense?
Oh, it does. And it also, obviously, then it still keeps the security between each leg of that, where you kind of pointed out. I know that I heard the explanation on the Tor sometimes with the triangle of where they actually have two legs to each side of their one server, and the others don't know about the, one doesn't know about the other two. So
well, in the traditional VPN, it's just a one connection. That's not the Tor part of it.
Right.
So
right.
You can add the Tor on top of that and then get, anonymization as well as encryption.
Okay.
Hey Peter, I wanted to, if I remember correctly, the proxy doesn't provide encryption itself, unlike VPN. VPN provide encryption, but proxy
Correct.
doesn't provide one. But only
Yes.
Tor Browser is the one who unify proxy characteristic along with the encryption. So that's why the Tor is secure or harder to track back. But if you're using like
Tor
proxy
itself doesn't encrypt, but you can transmit your stuff encrypted, and yes, that's a lot more secure.
Yeah, because like I just wanted to clarify that if you're actually putting that proxy on your Firefox or your Chrome browser setting, it doesn't actually encrypt at all, unlike VPN.
No.
It'll just gonna reroute.
Yep.
Just like most of the people are using either for confusing the location wise or wanted to hide your location per se, but
Right.
it doesn't come with actual encryption or safety feature at all. So when somebody wanted to investigate, it'll going to be easier to just track back one by one. Just only exception is the Tor browser that is kind of harder.
Yes,
So
it's a lot harder to do with the Tor browser.
yeah.
Of course, with the VPN, your data is only as secure as the people that you trust at the VPN site. And when you're doing, with the Tor browser, that's usually called the dark web, and whatever you're doing on the dark web is only as secure as that web server that you're connecting to. So those are both areas of penetration that have happened in the past. Let's put it that way.
I just want to clear it out because it looks like the one on the instruction looks like a proxy server is really hard to track back or whatnot, but when you actually trace it back, it'll be way easier than VPN. Just wanted to point it out.
Okay.
I think with the air gap too, I've got a better understanding now, because in discussion of multiple proxies and with conditions like being more anonymous or being less anonymous, you can control some of those things and thus create different levels of defense. As Gary pointed out, your first level is simply IP shifting, at various times, whatever that is. And if you IP shift enough, then no one can get a beat on you. But you also want to add, because they can still sometimes intercept pieces of your information and try to, use them. So you encrypt them. And on top of that, I'm getting the idea that even with the idea of you localizing, oh, here I am in Germany, you may not want that. If you've got very, very highly valuable information, you may want to have the server become more anonymous and work out, I guess, even better air gap methods between the two, to where you always have that interruption or less visibility. I guess the defense in depth technique applied even to the proxies.
Yeah, it sounds like that term air gap is a Microsoft term for their proxy architecture.
No, it's F5. F5 came up with
Oh,
that.
F5. Okay. Because in my mind, when I hear the term air gap, that means you isolate your network physically. There is a gap of air physically there. So that's the only, and so when you want to transfer data, you actually have to do it yourself with like a flash drive or something like that.
Traditional sneaker net, I think, is what
Exactly.
what that was.
Yep.
So Peter,
Yes.
So I don't know, you remember the competition? So you remember Squid, right? Isn't Squid a reverse proxy then?
In the competition, it was actually a forward proxy.
Oh, okay.
Yep. So that's why we couldn't get on the internet without the proxy, because it had everything blocked except for going through that proxy server.
I see. I got you.
Okay, so many of these, we talk about security with this, and then we've got a VPN, right? So secure sockets layer, the next gen of secure sockets layer is technically TLS, transport layer security. Actually, 3.0 has a security flaw in it. So you don't want to use secure sockets layer. You want to use technically TLS. TLS is the next gen. Transport layer security is the next gen. There's 1.1. You have to, and there's 1.2. These versions. There's 1.3. So you want to use the latest version of these, because other compromises have been seen in other of these 1.1 or 1.2. So transport layer security does the encryption. It's based on a certain encryption algorithm, and it's used in, this is secure shell, which is really a terminal. It's a secure terminal here. The secure shell is using SSL they use them interchangeably, SSL/TLS. It's using SSL/TLS to create this secure remote access. Okay. Same thing with HTTPS. Okay. It's not that it uses port 443 versus 80 with a regular HTTP. It's the fact that it's using SSL/TLS, okay, again, to create encrypted, and it's encrypted payloads. Okay, the payload is the section of your packet that has the data, just the portion of the data. That's what's being encrypted. And then VPN, well, you've got the encryption from above again, okay, SSL, TLS, encryption of the payload. But then you've got an encapsulation of the entire data stream, okay? The entire packet. End to end, right? End to end. But these are all using many of the same elements of security with this is encryption. This isn't, security is a big word that we reserve. Security, like we talked about, this is just encryption. Because security is physical security, it's it's digital security, it's encryption at rest and in transit. It's a lot of different things go into security or holistic security, but all these come into play here. Okay, so these proxy, so we've talked a little bit about this Tor network here. And like we talked about, these different proxy servers that's going through, usually 3 or more, those are volunteers, and they don't know about the owners of the other proxy servers. So everything is separate and unique, and it's not just going to 3 servers that are owned by some company. And so technically somebody could say, well, you own all 3 of these proxy servers, so why don't you tell me who it really was? Where did this actual packet originate? Where was the origin? They're all from separate people who don't know each other and don't communicate to each other. So it's part of, yeah, this is volunteer network here. Okay. Any other questions? So like Peter said, to truly be secure, it would be a combination of using this Tor network, going through multiple proxy servers. You could also use a VPN over Tor. All right. So you could add a VPN to that, and then your end-to-end encryption would be, the end-to-end tunnel would be secure, at least to the end point where the tunnel ends, and then the traffic continues without being tunneled.
I hope this is a really quick question. If not, Mark, we can always cover it later. But because of the number of these types of things that these proxies can do, is that driven by third-party software, or are there original router OSs that will now be able to be programmed, you know, like sending false IPs or restricting certain traffic types? So, I mean, I'm guessing here that a lot of it's software driven, but I was hoping there might be some more clarification on those.
Actually, they have both. Tor itself stands for the Onion router. So they actually have a OS version that you can install on a router, and it will act like a router and encrypt everybody's traffic. It becomes part of the Tor network, and not encrypts, but it becomes a proxy server on their network. You can also do the same. I want to say the browser does that too, but I'm not sure.
Okay. It's a good start. I've got so much in front of me to read. So yeah, I think that covers it pretty well.
Yeah, good question, actually. Cool. Okay, run out of time. If you are struggling with your VPN project, send an email to me or Peter, and we can work with you. If you have other questions or whatever, or just work with your team, other people in the class who've already done this, reach out to people in the class and ask them how they did it. And then just upload like a Word doc that has the picture of your phone and your laptop, and just upload it when you're done. And yeah, but don't wait till the last day, because it takes a little bit to get this working. Okay. We will talk to you then on Thursday.
Thanks, guys.
And I'm going to stop the recording.